Alright, this video is going to show you how to use the division property of square roots. And so the division property of square roots simply says that if you have the square root of a over b, that's the same thing as the square root of a over the square root of b. Or in terms of division, you can either do a divided by b and take the square root, or you can do the square root of a, the square root of b, and then divide it. All right, so let's look at a simple example here. So what we're saying, the square root of 64 over 49 is equivalent to the square root of 64 over the square root of 49. These are both perfect squares. So the square root of 64 is 8. The square root of 49 is 7. That can't be simplified, so that's it. Easy, right? All right, so let's look at this. So I have the square root of 45 and the square root of 4. Now, 45 is not a perfect square, but if hopefully you've watched my first lesson on radicals, if not, I'll put a link to it. It shows how to break this up in order to get a perfect square, in order to get a number out of this. And so what we would do with the square root of 45 is we would break it up into the square root of 9 times the square root of 5 all over the square root of 4, which I could have gone ahead and made that a 2, because the square root of 4 is 2. But square root of 9 is 3 times the square root of 5 over 2, and that would be your answer, because you can't simplify that any further. All right, so let's look at another one here. So we have square root of 36a over the square root of 4a to the third. I think I'm going to do this a different way. Let's do this a different way. We could do it this way, but now that I'm thinking about it, I think this other way might be easier. So here's what I'm thinking. Before we split this up, before we split this apart into the two pieces, let's see if we can simplify this. Because I'm noticing that 36 over 4 simplifies to 9. So that can be simplified to 1 and 9. And the a's, I can take this a and cancel it out with one of these a's, and that would change this to a to the second. So now let's see what we have. So now I'm going to go ahead and split it apart. So now I have the square root of 9, that's all that's left in the top, because this a canceled out one of the a's in the denominator, over a to the second. Because the 4 got canceled out with the 36, and I took away one of the a's. So now, these are both perfect squares. The square root of 9 is 3, and the square root of a squared is a, and that's your answer. I think that's going to be the easier way to go than what I started off with. Sometimes I start doing a problem, and I'm thinking of how I'm going to do it, and then I realize, it's probably an easier way. So I hope that didn't confuse you. All right, so let's look at one other thing here. This is called rationalizing denominators. And the point of this is that you can't leave a radical in a denominator. In algebra, we consider that unsimplified. So you should never have an answer of like 2 over the square root of 3. So what I'm going to show you is, well, how do we get rid of this? Okay? So let's break this apart. Let's start here. Nice, easy one. So I'm going to break this into the square root of 3 over the square root of 7. And there's nothing else that can be done to simplify this. So what I'm going to do to get rid of this down here is I'm going to multiply the numerator and denominator of this fraction by whatever this is in the denominator, which in this case is the square root of 7. So how can I do that? Well, the square root of 7 over the square root of 7 is just 1. Remember, you can do whatever you want to a fraction as long as you do it to both the top and the bottom as far as multiplying goes, because square root of 7 over the square root of 7 is 1, so I'm not really changing the value. So why did I do that? Well, the reason I did that is because the square root of 7 times the square root of 7, that would be the square root of 49. Let's do this. Up top, I have the square root of 21, and the square root of 49 is a perfect square. So I end up with square root of 21 over 7. And so that got rid of that. Now, whenever you take a radical times itself, it's always going to come out to whatever that number is there, the radicand. It's always going to come out to that. So like the square root of 12 times the square root of 12 is 12. All right, so let's look at another one. So I can't simplify this the way it is. So I have the square root of 6 over the square root of 25 into the ninth. Into the ninth is an odd exponent, so I'm going to have to split that up. I showed my previous video on this lesson showed that, so hopefully you know how to split that up to get something out of it. And so that's what we're going to do. I'm going to take the square root of 6. I'm going to go ahead and take the square root of 25 as 5. And then the n to the ninth, I'm going to split up into n to the 8th and n, because n to the 8th is a perfect square. And n to the 8th times n is the same thing as n to the ninth. So now I have square root of 6 over 5n to the 4th times the square root of n. And now here we are with the radical on the bottom. So what are we going to do? We're going to multiply the numerator and denominator by the square root of n. So in the top I have 6n, and that's under the square root radical symbol. Down in the bottom, square root of n times n is n. And then I'm going to multiply that times n to the 4th. So what I end up with, would like to show this more clearly, but I ran out of room. What I end up with is 5n to the 5th, because square root of n times square root of n is n. N to the 4th times n is n to the 5th. And that's your answer. All right, let's look at one more. So I have the square root of 5 over the square root of 18m squared. So m squared is perfect. Well, let me do it the way that I did it in my previous video, so that I don't want to confuse people. So I'm going to split up the 18 into 9 and 2. So 9 and 2. And I'm going to put the m squared with the 9 because it's a perfect square. So now I have the square root of 5 over the square root of 9 is 3. The square root of m squared is m times the square root of 2. I need to get rid of the square root of 2 down here. So I'm going to multiply the numerator and denominator by the square root of 2. Square root of 2. So in the numerator, I have the square root of 10 over, this will turn into 2, right? Square root of 2 times square root of 2 is 2. Multiply 2 times 3m, and you get 6m. And that's the answer. So I hope that was helpful. If so, give it a like and a subscribe. And until next time.